So today we are solving quadratic equations by completing the square, but these are going to be a little bit harder because they're going to have a number in front of x squared that's not just 1. So we're going to have to do a little extra work on these. But before we start, in order to understand how to complete the square, we have to understand the relationship between perfect squares of different forms of quadratics. So a perfect square quadratic in factored form, and here's a perfect square quadratic in an expanded form. And there's a relationship there that we have to understand. When we have it in expanded form, that number next to x, that 6, is related to the number in factored form because if we take this and divide by 2, we get that number in factored form. And that number in factored form is related to the number on the end of the expanded form because if we square that, we get the number on the end. And of course, these two numbers are related because if I know this number, I can just do both of those steps together to get that. In other words, if I take that 6 and divide it by 2, which would normally get me this, and then I take that answer and square it, I will get the 9. So take the 6, divide by 2, get 3. 3 squared is 9, will get me this. And that little relationship there will allow me to turn anything into a perfect square because all I have to do is look at this number and figure out what number do I need on the end to make this a perfect square. Take that divided by 2 and square it, and we'll know, okay? But notice this trick only works when you've got x squared with a coefficient that is 1, right? Because when there's no number in front of it, there's a 1 there. But if there's a number in front of there that's not 1, well, that changes our rule and it doesn't quite work. So we're going to have to find a way around that. And that's what we're going to do here today. Okay, so example, 3x squared plus 12x plus 11 equals 47. And again, we want to complete the square here, but we've got a number in front of x squared, so we can't use our rule yet. So here's what we're going to do. We're going to factor that 3 out of the parentheses so that x squared will be by itself. So I'm going to take that 3 and put it on the outside of the parentheses. Okay? So how can I do that? Well, I have to think 3 times what would have gotten me 3x squared? Well, 3 times x squared gets me 3x squared. All right? And similarly, I have to do the same thing with 12x. 3 times what gets me 12x? 3 times 4x equals 12x. So what I've done is I've taken that original expression and I factored the 3 out of it to put it in this form. It's almost the opposite of the distributive property, right? Like if you did the distributive property on what we ended up with, 3 times this, we get that. So we're doing the opposite of the distributive property. We're factoring the 3 out, okay? And I'm going to drop down everything else right there. But the reason we did that is now we've got our x squared by itself inside the parentheses. Now we can use that completing the square trick to make this into a perfect square. All right, so I've got a 4 next to my x term. So I'm going to use my little trick here of 4 divided by 2 and square it. 4 divided by 2 is 2. 2 squared is 4. So what I need inside that parentheses is to add 4 in there to make inside the parentheses a perfect square, okay? But what I do to one side of the equal sign, I have to do the other. So I'm also going to have to add 4 to the other side. But wait a minute. One thing to consider is, yes, it says I added 4 to this side of the equal sign, but I added 4 inside the parentheses. And remember, our parentheses are being multiplied by 3. So on this side of the equal sign, I didn't just add 4 on this side of this equal sign. I added 4 times 3. So if I'm adding 4 times 3 on one side of the equal sign, I need to add 4 times 3 on the other side as well to keep it balanced. All right. So let me write it out so we can really take a look at what we just did. I've got that 3 on the outside. X squared plus 4x plus 4 now on the inside of the parentheses. Drop down my 11, drop down my equals, and on the other side, I've got my 47 plus 4 times 3, which is 12. All right, but now you can see why we needed to add that 12 to this side, because remember, we added 4 to this side, but it's times 3. So we added 12 on this side, even though it kind of doesn't look like it because it's inside the parentheses. So to keep it balanced, we had to add 12 over there as well. Okay? So now, the whole reason we added that 4 in there was to make this a perfect square. So let's make that into a perfect square. All right, to make that into a perfect square, I'll take a look at that number next to x. It's a 4 and divided by 2. So positive 4 divided by 2, positive 2. So x plus 2 squared is equal to that. And if you're not sure, you don't believe it, you can always do x plus 2 times x plus 2 over on the side and see if it comes out to x squared plus 4x plus 4. Okay? But the trick is we just take that term next to x and divide by 2, and that's how we know what our squared term is. All right, so I'll drop down my plus 11, drop down to my equals. On the other side, I've got 47 plus 12, which is 59. All right, so far so good. Now, I can start solving this equation now because I can just use inverse operations in algebra. I'm going to subtract 11 on both sides. When I do that, I get 3 times x plus 2 squared equals 48. Now, I've got to undo that 3 before I can undo that squared. So I'll divide by 3 on both sides. I've got x plus 2 squared equals 16 now. I'm almost there. I still have to undo the squared before I get to that x. So I'm going to square root both sides. Squaring and square rooting undo each other. So I get x plus 2 equals, now be careful here. When we square root both sides of an algebra equation, there's 2 possible answers. It could be positive or negative. So I'll put the plus or minus there. And the square root of 16 is 4. So that tells us it could be positive 4 or negative 4 in that step. And our last step, to undo the plus 2, I'm going to minus 2 on both sides. When I do that, I get x equals plus or minus 4 minus 2, meaning positive 4 minus 2, which is 2, or negative 2 minus 2, which is negative 6, and those are our 2 possible solutions, okay? So there's a lot to kind of keep in mind here. We've got to factor out the number to get x squared by itself. We've got to add in a number to make this a perfect square. But what you do to one side, you have to do the other, remembering that even though we're adding 4 to this side, we were multiplying it by something, so we also had to multiply it on this side. We had to make our perfect square, and then we had to start solving it. And when we square rooted on both sides, we had a plus or minus answer here because there's 2 possible numbers that could be the square root of 16. So we end up with 2 possible answers here. Okay, so let's do one more example so you can see it one more time. This one's going to be slightly harder this time. We've got 2x squared minus 12x minus 7 equals 17. So just like last time, let's complete the square on this. Okay, so I'm going to put parentheses around 2x squared minus 12x, and I want to complete the square, but I've got a number next to x squared. So again, I'm going to factor out that number next to x squared. Okay, I'm going to factor out the 2. 2 times x squared is 2x squared. 2 times what gets me negative 12x? Oh, 2 times negative 6x. Because 2 times negative 6x is negative 12x. I just factored the 2 out of my expression there. And I'll drop down my minus 7 and my equals 17. All right, so far so good. Now, I need to figure out how to make that a perfect square. So I need to figure out what do I need to add inside the parentheses. So I'll take that negative 6 divided by 2 and square it. And that'll tell me what I need to add. Negative 6 divided by 2 is negative 3. Negative 3 squared is positive 9. So I'm going to have to add 9 inside the parentheses to make it a perfect square. But of course, what I do to one side, I have to do to the other. But also, remember, I'm not actually just adding 9 to this side. I'm adding 9 to this side inside the parentheses, which is then being multiplied by 2. So I'm not just adding 9 to this side, I'm adding 9 times 2. So I can't just add 9 to this side. I also have to add 9 times 2 on that side to keep everything balanced. All right, so let's see what we end up with here. 2 on the outside x squared minus 6x plus 9 on the inside of the parentheses and drop down my minus 7 equals, on the other side I've got 17 plus 9 times 2. 9 times 2 is 18. So now I've got that. All right. It looks like a mess, but let's clean it up a little bit because this is a perfect square. What perfect square is it? Well, we know there's an x there, and we just take half of the x term in the middle here. What's half of negative 6? Negative 3. This becomes x minus 3 squared. Drop down my minus 7, drop down my equals. On the other side, 17 plus 18 is 35. And now this is looking a lot easier to deal with, and I can solve this equation. All right? So to get to x, I'm going to have to undo everything around it, starting with that minus 7. So I'm going to plus 7 on both sides. When I do that, these undo each other. 2 times x minus 3 squared on one side, 42 on the other. Then I'm going to divide by 2 so I can get rid of that 2 right there. When I do that, I get x minus 3 squared equals 21. Now, to get x, I'm going to have to undo that squared, so I'm going to square root both sides. When I do that, squaring and square rooting undo each other, so x minus 3 drops down, equals drops down. Now, don't forget, I square rooted both sides, so that means I'm going to have 2 answers, plus or minus. The square root of 21 is irrational, so I'm just going to leave it as the square root of 21. It's going to be some kind of decimal, like 4 point something, but I'm going to keep it irrational to keep it nice and clean and neat and tidy and more precise. All right, so I'm almost done. I've got x, but I've got to undo this minus 3. So I'm going to add 3 to both sides. When I do that, these undo each other. X drops down, equals drops down, and here are my 2 answers. Plus or minus the square root of 21 plus 3. So in other words, one answer is the positive square root of 21 plus 3. The other possible answer is negative square root of 21 plus 3. Those are my 2 solutions, okay? So a lot of steps here, but nothing super complicated. There's just a lot to remember, and it just takes some practice. But the key here is factor out the number next to x squared, figure out what number makes it a perfect square, and make it into a perfect square. Solve one step at a time, but remember, when you square root both sides, there's 2 possible answers, a plus or minus, and then find those 2 answers. Okay, hopefully this video helped you. If it did, please hit that like button and also subscribe because it really helps us out. But with that being said, good luck on your math, and I will see you next time.